So hi guys, let's try solving another leetcode sliding window technique problem. So the question is longest repeating character replacement is a medium leetcode problem. So let's understand the question now. So we are given a string and an integer k. We have to choose any character of the string and change it to any uppercase English character. You can perform this operation at most 8 times. So let's try answering the first test case. So A B is there. So k is value is 2. So we can do up to 2 replacements in any given string substring such that we get the longest repeating characters such that like whichever is in majority A is there we can do two operations so B and B can be replaced by A so we'll get four. That's not a problem. Let's try understanding the test case too. So A B A A B A B A. So let's try understanding this test case. So this string is that we can do up to one replacement. So k is equal to one. So here right now A B is there. So we'll try replacing this B. So here let's first find out whichever are lesser in number. So as you can see here B's are less in number. So let's consider one replace. Like if we consider first B is present and we replace it by A. So right now we have four A's. So four A's are present. So the maximum length right now would be four. If we now we can only do one replacement. So you just imagine we do a replacement for this B which is present here. Just consider this B which is present. If you do one replacement here, it won't make any sense because you get just a size of two. So we have to find a window. We are using sliding window technique. So we have to find the windows that you can do. You can do less number of replacements and get the maximum longest, like the maximum size of the window. So let's think of an approach. So we will use a hash map. The hash map keeps a track of the characters which are present, A's and B's. Like A's and B's. Actually, right now in these test cases, you can see there are only A's and B's. But normally the S can contain any number of characters in it, A to Z, any number. So instead of using a hash map, we would use a character array, not a character array, a number array which will show the ASCII values of the characters, alphabets one by one. So we can create a 26 size array. So right now let's try adding our approach. So let's consider the second test case and try our approach on it. A B A B C A, and then K is equal to 1. So consider this. Yeah. So just right now this in a sliding window is kind of template which you can use it to solve many questions. Actually, initially sliding window seems hard, but as you do it, you'll find it easy because you can see a repetition in the technique which is being applied in the question. So let's consider a high and a low pointer. These lines are the pointers which are present. So A and A initially high and low both are zero. So we would right now we can do any replacement. So we can move the high pointer by one, and again I move it. I move it again. I move it again. Right now, how many A's are there? There are two A's, and the size is two right now. I'll keep a count of the size. The size is equal to two, yeah. And then we move one more time. We move the pointer. So B is present. So B we replace B. So size right now is three. So we can't move. We can move this pointer once more. So the size is four. Yeah. So size is four. So we'll right now says we can't move this pointer once more because it will become one more replacement. So right now in a sliding window, once the condition is satisfied, we can't move anymore. We move the low pointer. And right now we move the low pointer by again. We will move this low pointer by one. So wait a minute. So yeah, this low pointer will go by one. The condition is still satisfied, and then I would I would move the low pointer again. Size is 2. Condition is satisfied. But the low pointer can't cross or can't be equal to the high pointer. So I would move this once more, this low pointer once more. So now, yeah, so now this can't cross. So now we'll move the high pointer. High pointer will move right now one replacement. So right now the size is 2. We can't move the pointer one. This is how it works. Let's code it out. After coding it out, we'll get clarity on the question. So, so we'll create a low pointer. See the sliding note technique problems are all the same. So we have a low pointer initial position, and then we create a character array. It will be of size 26 because those are all lowercase, sorry, uppercase characters. So, yeah, so we'll keep a track of the maximum count like whichever is more, A is more or B is more. We'll keep a count of that. So if we get to know that A is in majority, so we would obviously not replace A. We would replace B to get the maximum size. So initially keep that 0, and then we will keep the max length. So this contains the answer. So this is basically the answer. We keep a track of the maximum length each time. And now for loop of the high pointer. High pointer plus. So now height will be I just oh sorry. So yeah. So now this high pointer will go for. So high starts from. So now whichever while iterating, whichever character we get from string, we would add it to our hash map. So we are of the character of the string which is present at the high pointer minus a. So this is the way of hashing your such that you get only 26 characters. You can hash it in that way. So we would increase its value in the array, and then next step would be we have to increase the value. Now we'll get the frequency. So we'll keep a track of the frequency. So dot char next high. Yeah. So we would have the frequency in hand of the incoming character. Okay, and then we would have the max count needs to be updated. So each time the incoming character comes, we have to see what the maximum count is, like whether we have to change it or whether we have to keep it the same. Okay, so is equal to max count is equal to the, the max value of the max count and frequency. Yeah. So now this is all good because it would go the high point should move out. Now we have to even move the low point. Right now the condition is satisfied. Now I have to even move the low pointer. So there's a condition inside the while loop that we'll able to understand that first. So the size of the window is given by this is the formula for the size of the window. It's going to be high minus low plus one. This is the size of the window. So let's consider a small test case because this part is very important and crucial. So A, B, A. For example, in this you see, let's consider this window. I would even add the indexes so that we can understand it better. Uh, 1, 2, 3, 4, 5, 6. Yeah, these indexes. Like consider the window from 0 to 3. So let's focus on this. Yeah, from 0 to 3. In this you can see from 0 to 3. 3 minus 0. 3 minus 0 is plus 1 gives you the window size which is 4. So if I remove the frequency of A right now, the frequency of A is 3. So 3 plus 1 minus 3 is how much? It gives you 1. So 1 is the frequency the of the replacements which you have to do, which have to be done. So that will give you a frequency. So we'll add a while loop. So it's going to be high minus low plus 1 minus the max count. You have to make sure it's less than k. Till then we can do. Till it's less than k, we'll move the low pointer. Till it's greater than k, we'll move the low pointer. Once the condition is not satisfied, we'll exit the while loop. So let's decrease the frequency from the low pointer. So whichever is present at low pointer, we'll remove those till then. We keep removing it. And yeah, we do a minus minus because we have to remove the frequencies. Okay. And then we have to do low plus plus because we're removing the low pointer off. And then we will print out after the whole process, we will print out the maximum value. We'll keep a track. So max length is nothing but the math.max or max length and the frequency, not the frequency, the window length. So window length, as you know it, it's a high minus low plus 1. So in the ending, we would return the max length, and that will be the answer. So let's test our code right now. Yeah, so A B. Let's try for a custom test case. Yeah, this is a very good test case. That's why we're using this for every. So how many? The answer should come four. No, I think we haven't given the semicolons. Yeah, so four replacements. So let's try submitting the code and check our accuracy. Yeah, so that's it. I hope you people understood it. Thank you.